we've got folks here from maybe even a few countries, but we want to say hello from Muskingum County, Zanesville, Ohio. We're actually at the 175th Muskingum Blue Ribbon Fair tonight. The Muskingum County commissioners helped make this possible, and we want to thank Neil for sharing his evening with us, and we just look forward to a good night of information and sharing. And this is something we do every month. It's called Farming After Dark, Finding a Better Way, giving people an opportunity to maybe hear different information. We've had stuff on soils and wildlife and pollinators and beneficial insects, and Neil's message just kind of fits into that regime. So Neil, with that, enlighten us.
All right. Well, first I'd like to say thank you, Van, for having me, and thanks for all of you that are joining online. Just in a way of a little bit of introduction for those that don't know me, I grew up on farms in southeast Missouri and southern Illinois. Our major crops were corn, soybeans, wheat, and cotton. In 1973, I formed Kinsey's Agricultural Services and began working with the farmers just in the local area. Never thought I'd work anywhere else. Today, we work in 75 countries with all major food and fiber crops. Our business is basically taking soil tests, interpreting what needs to be done for proper fertility, solving problems, crop problems, soil problems, so forth. We also use GPS where people have that capability to get a variable rate, use variable rate technology in order to get a more precise liming and fertilizer application done. We conduct advanced and training courses, introductory training courses. There are about 6 different types of courses we conduct for growers and consultants and fertilizer companies. And we do on-farm consultations. That's what Kinsey's Agricultural Services is about. When I speak to farmers, and we speak to farmers in several countries over the world, but generally always when you go there, the farmers and growers will say, well, you know, maybe this works in Missouri where you are. It was developed by Dr. William Albrecht at University of Missouri, but our soils are different. I don't think it'll work here. Well, I say, yes, your soils are different, but even if you have a clay soil, all clay soils are not the same. If you farm sand, all sands are not the same. Quite different from one to another. As a matter of fact, how many different soil do you have on your own land? You know, you can go out there and look. Well, some of them are quite different. Most of the time, they're not all the same. How do you make that work? Well, no matter how many or how different the soils are on your land, if we stick with the basic laws of science, those don't change. Anywhere in the world, the laws of science are the same. Gravity still works the same. Chemistry, physics, and biology still work the same, no matter where we are. What we need is a system that works using these basic laws of science to show what's required for the soil to do their best. That's where we try to use our soil test to evaluate the soils and what needs to be done. When you start looking at a soil, there's the biological aspects, the physical aspects, and the chemical aspects. To look at soil health, we really need to look at all of them, but the one we're really generally try to focus on is the biological aspect when it comes to soil health. What a lot of people don't stop to think about is, without the proper physical characteristics in the soil, we don't have the right house for the biology. How do you get the physical characteristics there if you don't have them? Well, you have to go back to the soil chemistry. So what the program we use always emphasizes is we use soil chemistry to correct the physical structure of the soil. And that physical structure has to do with the amount of minerals, air, and water that's there, and to a certain extent, the organic matter or humus. And the physical structure of that soil then determines what the environment is for the biology. So even though ultimately we're looking to try to influence biology as soil health, unless we have the proper physical structure, it won't work. And if we don't have the physical structure, most soils don't really have it, then we have to use chemistry to determine what it is now and what it needs to be. All soil have at least one thing in common. They need living organisms to feed the crops. And generally, when we're talking about healthy soil, we're talking about a soil that supports the plant root and everything that's there that helps that plant grow properly. In our work with soil health, we use what's called the Albrecht system of soil fertility. A lot of people don't realize that Dr. William Albrecht, when he was hired at University of Missouri, was hired as a soil microbiologist. That was his job, soil microbiology. He was there to try to help the microbiology in soils work better. And his first job was to teach the farmers that would rely on University of Missouri how to use the proper rhizobium inoculant to get the legumes in their pastures and so forth to grow better. The university thought, Dr. Albrecht thought, a lot of people thought, well, if we just use the right inoculant on our alfalfa or our clover or our lespedeza or our beans, well, then we can solve the problem of why these aren't growing well. The thing about it is sometimes it worked well, sometimes it didn't. Even on some farms, a part of the field responded great to the rhizobium inoculant, and another part didn't seem like it made that much difference at all. So then Dr. Albrecht started looking at, well, what's the difference between the soils where it's doing proper, getting the proper response, and where it's not? And they started to see certain relationships. Well, in terms of then using the soil samples where the inoculants were working properly and the crops were growing good, they found that the closer they could correct the soils that weren't doing well to that, the better response they got from the inoculant. In other words, we have to have the nutrients there, the right nutrients or the right relationships in order for the inoculant to do its best. Some of those farmers were dairymen, and they'd take their alfalfa ground after they got it straightened out, for example, and well, sooner or later, they maybe went to corn silage or some other crop. But all of a sudden, the farmers started coming back and saying, well, you know where the legumes have been doing the best, and we corrected it. Now the corn silage and the other crops are also doing their best. So all of a sudden, Dr. Albrecht started to put together, well, look, there is a basic foundation that all soils need in order to get the proper response from whatever crop you want to grow there. And there's a lot of ways we could start, but here is a chart that you see in basically all the agronomy books in one way or another. It may not be exactly like this, but this defines the characteristics of an ideal soil. 45 to 47% minerals, 3 to 5% humus. Together, that makes up 50% of what we call the ideal soil. The other side is space. 25% of that space, 25% of the total of that pie should be air, 50% of the pore space, and the other should be water. So an ideal soil has 25% water, 25% air, about 45% mineral, and 5% humus, if you want to talk ideal. The only thing is that defines an ideal soil, but most soils are not ideal. And the question is then, if we need the ideal soil to have a healthy soil where all the biology thrives, how do we get it if we don't have it? There was a Russian soil microbiologist, N.S. Krasilnikov. He worked in the last century, and his work was considered as so important that USDA actually took his major volume, I think it was 200 and some pages of work, and translated it from Russian into the US, and it is available as far as to be able to get the translation and read in English what he found. But basically what he saw was soil fertility is determined by biological factors, mainly by microorganisms. In all his lifetime work, this is what he came up with. And he tells why in this translation. but the development of life in the soil provides it with the property of fertility. He says fertile soil is created by microorganisms. Where this life is dead or it doesn't work, the former soil would become an object of geology, not biology. In other words, without life in the soil, it's dead. It's not really doing what we need in order to produce a crop. If you take soil from the moon, when they brought the soil back from the moon and looked at it, it didn't have any living organisms in it. You plant a seed in that, it didn't work well because it was not a living soil. It takes life in that soil. So to have a healthy soil, one way to measure it is by looking at the amount of microorganisms, or not just micro, but earthworms, all the living organisms in that soil. Now, this is in kilos per hectare rather than pounds per acre. If you're not familiar with kilos per hectare, you can take the kilos per hectare and take 10% off, and that's approximately the same as pounds per acre. So if we look at bacteria in 20 centimeters of soil would be about the top 8 inches. So we take 8 inches of soil and measure all the bacteria in an acre of that soil, and it weighs about 1,700 kilos per hectare, or just a little over 1,500 pounds per acre. If you take all the fungi, 2,700 kilos per hectare, well, in pounds per acre, take off about 300, that's close. 2,400 pounds of fungi in an acre of soil 8 inches deep. Protozoa, not so much, about 135 pounds per acre. Arthropods and algae, about 900 pounds, and earthworms, about 900 pounds. When you add all that together, that turns out that if you add all this life together that's in 8 inches of soil in 1 acre, weighs about 6,000 pounds. Now, all that stuff's got to eat. And so when we start looking at crops and growing crops and say, all we need to do is put down the amount we need to grow the crop, we are always going to short ourselves in terms of the potential of the land. We have to feed those organisms to keep the soil healthy so that those organisms can do their job in order to provide all the various things that they supply so that the plant can be supported and healthy. When you start getting an idea, well, we don't need to feed the soil. All we need to do is feed the plant. You start shorting yourself on the potential of your soil, and I'm going to try to show you why as we go further. But imagine this, 6,000 pounds of something in this soil, in every acre in the top 8 inches, they're taking nutrients. They're taking nutrients just like our crops do and so forth, which means used to, various people would say, well, that's like feeding 1 cow per acre plus the crop. No, it's not. It's more like 4 cows per acre. If you take a brown Swiss cow, she weighs about 1,500 pounds. If we've got 6,000 pounds of organisms that are eating in that soil, that's like we got to feed 4 cows what they need before the crop gets what it needs, because there's an old saying in microbiology, and it's true. The crops all eat at the second table. The other organisms in the soil get what they need first. As a proof of that, I think any farmer out there would tell you they've seen where they've worked residues into the soil, like crop residues or something, and there wasn't enough nitrogen there to feed the crop and break down the residue. Well, which gets robbed? The crop gets robbed. We don't have enough nitrogen for the crop because the microbes take the nitrogen to break down the residues first. Anything that's worth doing is worth doing right, and the real long-term solutions are not normally the easiest to accomplish. You have to put forth effort to help even the best solutions work properly. This is what we find with farmers all the time. It isn't just a matter of saying, well, I think I'll just put some fertilizer out there and I'll find out what the crop needs and we'll make it work. We need to find out what the soil needs in order to get the soil to work best, in order to get the crop to grow best. Every difference you can see in your soil, if you walk out on your farm, every difference you can see, whether it's a different color, whether it's a different slope, whether it's a different consistency from sand to clay to all in between, every difference you can see in your soil or in your crop generally reflects a difference in soil fertility and consequently soil health, because they go hand in hand. Every weed is in your field because of something that has been done or is not being done, which fails to promote proper health. Don't know how many of you are familiar with the weed that's pictured in that picture, but we call it sour dock. There's a sour dock and a curly dock, just depending on the leaf structure. Well, I used to be told that that's because we have sour soil. Sour dock grows in sour soil. It does grow in low pH soil. But you know what? I've seen this same weed grow in soil that have pH above 8 in sugar beet fields in California. That's not a sour soil. That's sweet soil. That weed's still there. But you know what I've never seen? I've never seen this weed grow in a soil that has 65 to 70% saturation of calcium. And if you don't have it and you put your calcium there, it will quit growing. Now, I'm not saying it'll quit and die just now, but you come in there and this weed that's growing here, you put the proper amount of calcium on, next year you won't have to worry about that they're coming back. There's always something that's missing. And we may not always know what it is because we're not trained to study that. We're not studying for taking a look at the weeds. Well, why is that weed there? And every different weed's there for a different reason. I'm not saying we know them all, but I will tell you this. This was our plague when I grew up, cuckleburr, not at this side, but taller than the soybeans. What we found when we started working with Dr. Albrecht's program is, first of all, cuckleburrs like a very tight soil to germinate in, but they like two other things: low percentage saturation of calcium and low zinc. Where you have low zinc and low calcium, cuckleburrs can thrive because they can get all they need of both, whereas the other crops that we're trying to grow can't. That gives that cuckleburr a big advantage if we can't get it under control early. Every disease, not just weeds, but every disease in your crop is there because something that has not been done or that has been done, which failed to promote good soil health. What you're seeing here is an experiment that was reported by the American Phytopathological Society. And they did studies where they looked at what caused take-all disease in wheat. Every one of these randomized replicated plots where the take-all disease is in the wheat has severe copper deficiency. Now, you'll have people tell you, oh, it's this, it's this, it's this. We've never been able to solve take-all disease in wheat. Get all the other nutrients that we know to get there, but until we get the copper above 2 parts per million, on the tests that we use, other tests, the numbers are different. But when you get when you get sufficient copper there so that it would measure 2 parts per million on our test, farmer after farmer will tell you, we don't have take-all disease in our wheat anymore. It's a nutrient deficiency. Take-all disease in wheat will always be a problem if you don't have enough copper. Now, I'm not saying other things that don't figure in there, but generally copper is the last one that gets corrected. This is one of our clients. He raises, well, several thousand acres of soybeans, but his parents started with our program in the 1970s. And what he'll tell you is they built all the levels up then. And today, when other farmers around him were spraying for Brazilian soybean rust and making on an average of 8 bushel more per acre, he said, you walk out in my fields, you can't find Brazilian soybean rust because their copper levels are high enough. It just doesn't proliferate there. Keeping the copper levels high, and 2 parts per million is not enough to assure you don't have Brazilian soybean rust. But he's not opposed to doing it. He's even tried using it. And he said, look, we can't even justify the cost of the going through the field and the application. We just don't get enough extra yield. Now, he gets really top yields from his soybeans. But in this case, it takes between 4 and 5 parts per million copper. And all the other nutrients that are needed to make that copper work properly. But what he'll tell you is you can walk on all of his farms and you can't find Brazilian soybean rust. And we have a number of other people that will say the same. It also applies to sudden death syndrome in soybeans. What matters most? Farmers need to know how to quickly treat a problem. Yes, we need to know that. But if all you do is treat the problem without solving it, it just keeps coming back over and over and over again. An example can be cutworm in corn. It's not just cutworm. Every insect is in your crop because of something that has been done or has not been done, which failed to promote good soil or plant health, maybe both. In terms of a cutworm, there's one simple solution. If farmers followed, you wouldn't have cutworm in your corn. Now, when I say that, there's always differences in a field. But once you get this corrected, and what is the key? Every client we have that had problem with cutworm in corn, we've always found it doesn't matter what the pH is. Their pH may be in the high 7s. But if you don't have a high enough percentage of calcium in your soil, cutworm is going to be a problem. Doesn't matter what the pH is. It matters what the calcium percentage is. What percent of that soil has calcium saturation? And every client we have that we've been able to get on medium to heavy soil, that we've been able to get the calcium up into that 68 to 70% range, they'll tell you they don't have a problem with cutworm anymore. One farmer got rid of his cutworm problem, and then 2 or 3 years later, he called and he said, Neil, got cutworms again. Well, we just checked his soil that year. He didn't need limestone. He didn't need calcium. I said, well, where are they? Well, they're in the low spots. Well, everywhere where there was a low spot in this field, when you get quite a bit of rain or when you use furrow irrigation, which he used, they've got places that don't drain out well. And where that water stands is where they also get the most concentration of nitrogen. And the nitrogen in that area, when it leaves, when it converts to nitrate and is not used, it then converts to nitric acid, about 85% of it does. And that nitric acid latches onto calcium and pulls it out. When you go back and analyze those places where the cutworms were, there wasn't enough calcium there. The rest of the field had it, and guess what? They didn't move out of those areas from one to the other. That's why we say there's something always, these things are indicating problems to us. If we've got this problem, there's something wrong. It's not that everything's right, and it's just, I'm not saying it never happened. I mean, a plague of locusts, they're going to eat everything. But when we start seeing something like cutworm in corn, if we can get the client to correct his calcium, then he'll tell you, I don't have a problem with cutworm in corn. As a point here, insecticide affect many soil organisms. This is a quote actually from Dr. Jill Clapperton, who's a microbiologist. Well, she worked in US and Canada. I think presently she's living in Montana, out that way somewhere. But anyhow, she made the statement, insecticides affect many soil organisms, even though they may not be classed as insects. They are closely related organisms. When we come out and spray for cutworm, when we come out and spray for whatever, it doesn't just kill the cutworms. We also affect a lot of the other biology in that soil. We need a long-term solution. We need long-term solutions that stop what causes the problem, not just treating the effects. The best solutions are not to kill everything but the crop, because that's what happens when we start trying to kill one thing. We kill a lot of things. Here's an example. 1994, I put on a meeting for a group of berry growers in California. After the meeting was over, one of the guys came to me. He said, Neil, I raised 200 acres of raspberries. And he said, I'd like to raise organic raspberries, but I can't, because we've done experiments to see what happens if we don't use fumigation, and we lose 15,000 pounds of production per acre. And I can't afford that in terms of all that we have in terms of growing the raspberries. Well, when a farmer does an experiment, where does he go? Usually, if he's going to experiment in something like that, he's not going to use his good land. He's going to use his poor stuff. In fact, you asked, in his case, he took some of the worst land he had and left that out and didn't fumigate it. Well, once we analyzed his soils and found out where he had soils that actually matched up to what Dr. Albrecht would say was the ideal soil, there he ran tests, and guess what he said? We didn't lose any production at all. It wasn't a matter that these things were going to hurt you where you had the right nutrients. It was where you didn't. That was 1994. He's since not as active as he used to be. I won't say retired, but his family still, he started out just right in the mid 1990s and was raising 170 to 200 acres of certified organic raspberries. And his family still does it today because they found out what the key was and they didn't have to fumigate anymore. Now, I'm not saying we can solve every problem that way, but I would think if we started using our science to try to find out solutions rather than saying, well, we'll just take care of it all at once, where would we be in terms of healthy soil? I think we'd have a lot more health than we do. The best answers to soil problems is how do we help the soil stay alive and well? That's soil health. That's the key to soil health. How do we keep it alive and well? First time I was asked to speak to the no-till convention from the National No-Till Conference, I asked, what do you want me to speak about? And they said, we want you to speak about soil health. I said, that's the number one thing every no-till farmer says he wants to hear about at the conference is how do we get a healthier soil? Well, when you start talking about soil health, the first thing you need to talk about is what is it that stimulates biological activity in a soil? The second law of thermodynamics says life only comes from life. I remember when I was studying under Dr. Albrecht, he used an example when he'd say life only comes from life. He said, once they learned to isolate the humus in the soil and could actually take all the humus out of the soil, he said, when you do that, the soil's dead. And he said, you can take seed and put in that so-called soil and it will not germinate. But he said, you just take a very, very minute amount of humus and add it to that soil and all of a sudden those seeds germinate. He said, it takes life in the soil just to get a seed to germinate. And if you kill all the life out of the soil, a seed won't even germinate. I'm not saying that we have to have optimum conditions. I'm just saying that shows life only comes from life. Well, it helps show that. When we look at soil organisms, what do? Well, first of all, if you analyze your soils right after you harvest and you got a lot of residues on the soil, that's when you'll always see your phosphorus and potassium at its lowest level. If let's say it's corn and soybeans, and you come in the spring, you analyze it in the fall, and you come back in the spring, and you analyze it, say, April or May. Generally May, if you're in the corn, before the corn gets belt high, so it's not pulling a lot of nutrients out. If you analyze the same depth, the same field, and so forth, what you'll find is the P and K is a whole lot higher in the spring than it is in the fall. Why? Because the microbe broke down those residues. To the extent the residues get broken down, they add especially measurable amounts of P and K. We also need organisms to form the humus in the soil. And I won't get into that because of time, but if we don't have the proper microorganisms, we're not going to be able to build humus. The thing that most people forget is this third one, release of plant nutrient elements from insoluble inorganic soil minerals. If we stimulate microbial activity in the soil and do that sufficiently enough, you can do it with manure, you can do it with compost, you can do it with biological stimulants. If you get enough stimulation there, you can actually measure the amount of increase of especially P and K. Those are the two that generally show up easiest, phosphorus and potassium. And we've actually seen places where a farmer would put on 4 tons of compost and measure all the phosphate and potassium that's in the compost. And after he's done that for 3 or 4 years in a row on places that actually need it, after he'd done that for 3 or 4 years in a row, all of a sudden, the P and K starts going up by more than the amount he's putting on, and he's still taking off a good crop. How can that happen? Only one explanation. The life in that soil is starting to take those insoluble inorganic soil minerals. Do we have much of that? The 1957 USDA Yearbook of Agriculture entitled Soil actually makes a statement in there on potassium, and it says the average Midwestern soil has from 35 to 50,000 pounds of potassium in the top 6.5 inch, well, the aerobic zone, which is about 6.5 to 7 inches deep. 35 to 50,000 pounds of potassium is there on every acre, but it's not in the form the plant needs. If it were, we'd be in if it were, we'd be in trouble because that's way too much. But if we had enough there from that, or if we can release enough from it, we can actually get to the point where we'll tell farmers, you don't need to go buy some potassium this year. And I'm not against potassium. I'm not against phosphorus. We work with clients, and whatever the test shows they need, then if it shows you're short on it, don't wait on the microbes to do it. You need to take care of it now if you're going to grow the crop properly this year. We also use soil organisms, those rhizobium bacteria we talked about and others that fix nitrogen for the soil. It also improves the mycorrhizal relationships, which has a great effect on, especially for corn and crops like that, on the mycorrhiza pulling the phosphorus into the corn. And it's also, soil organisms are antagonistic to plant pathogens. Now, let's not get into all that at the moment, but just to say, we need them for that and to improve soil properties. On that improving soil properties, if you take an old soil that's just as hard as can be, when it dries out, it's hard. Take about 12 inches of mulch and put on top of it. Keep enough moisture that it stays moist underneath, and see what happens after that mulch gets down to about 3 or 4 inches, because what will happen is it'll actually soften up that soil. So you got to have the microbe breaking down those residues though, in order for that to happen. Here's the key. The soil is the plant's only stomach. That is the plant's stomach. The soil is. Plant doesn't have a stomach. If we mess up the soil, we messed up the stomach of the plant. So what we try to do is start looking, okay, what is it that stimulates the activity of the microbes and so forth that digest the nutrients in the soil in order to go into the plant? A medical doctor who actually started working with soils in the Germanic speaking countries, Dr. Rausch, actually studied microbiology in the human stomach. And then when he started studying soils and plants, he said the same organisms do the digesting in the soil for the plants that do the digesting in our stomach. Those organisms that we need to digest our food are the organisms that the plants need to digest theirs too. If we mess up our stomach, then what happens? Well, we have health problems one way or another. It's going to be the same thing if we mess up the soil, because we cause a problem with the plant stomach. Soil organic matter, some people say SON, soil organic matter is the primary food source for most soil organisms. Crops with the most roots generally provide the best source of organic matter. So growing a lot of root systems, keeping underneath the soil where it's moist and the microbes can get to it, that's a good way to, soil organic matter is a good way to make sure we have a good food source for soil microorganisms. That means cover crops or keeping something on the land all the time. In terms of pastures, we've had clients who have had pastures for all the time they've been farming, and then all of a sudden, when corn prices and bean prices went up back before the turn of the century, a number of those guys said, well, we're going to take this pasture out. It's flat enough. We're going to take the pasture out and grow corn and soybean. We saw pastures that had 4 and 5% humus levels. And in 2 years, they'd gone from 4 and 5% down to 2 or 2.5%. They'd dropped in half because they didn't, when they came and took those pastures out, there wasn't any effort to keep it covered. It was a conventional till process. And once you start doing that, if we don't keep food sources there, the biological portion of the soil can't do its job. When you want to build humus, 70% of the aerobic bacteria in the soil, the bacteria that work with air, which is the ones that make the humus, 70% of the aerobic bacteria work in the top 2 inches of soil, and 70% of the humus is formed in the top 2 inches of soil. So that means if we mess up that top 2 inches, we've messed up a good source of building humus in our soil. In terms of 5 inches, 95% of the aerobic bacteria in the top 5 inches, you can find out where all the aerobes are by just taking an old wooden fence post and pulling it out where, if you've got a chance to do something like that. And the aerobic zone is as deep as that fence post rots. So 5 inches, 95% of the aerobes are there, but generally you'll find they go somewhere between 6 and 8 inches. Most of the time, 6 3/4 to 7 inches would be a a rule of thumb. But if you want to build humus in the soil and you start putting all your residues down 8 or 9 inches, like many of the farmers that used to plow, they plow 9 inches deep and put all the corn stalks down 9 inches. We just put it down to so low, the aerobic bacteria can't do their job properly. If you want to build humus, get your residues into, as much as possible, the top 2 inches, and at least, if at all possible, in the top 5 inches. To maintain soil humus, keep the soil covered. As I said, in the pastures, we saw the humus drop by 50%. And this is the colloidal humus in that soil. It's not looking at total organic matter. We're looking at colloidal humus, and it dropped by 50% in 2 years, just by not keeping the soil covered and keeping something there for the microbes to help them keep up on in supplying that humus. Continuous cover, you get better soil life, better soil health, if you can keep something there all the time. Organic matter helps build soil humus because of the cellulose and lignin that's in it. And that takes time to break down. It isn't something that's just going to break down really quick, but it's a longer period of breakdown. But unless we keep the carbon and the nitrogen balanced out there so that we've got at least 1 pound of nitrogen for every 10 to 20 pounds of carbon, we're not going to build the humus anyway. You can have a lot of trash there, but we have to have a balance between the nitrogen and the carbon. Organic matter, we talk about humus, and some people use those terms interchangeably. Humus is organic matter or things that have been living that's broken down so finely that it can't be broken down any further. When you break down living organism to the point they can't be broken down anymore, that's true humus. Organic matter is anything that's still there, whether it's broken down. Humus is organic matter, but organic matter is not necessarily humus. Organic matter is the crop residues, the leaves, the wood, anything that's been alive that hasn't been completely broken down yet can still be considered as organic matter. But when we can get that organic matter to be broken down into the soil, just having that material there, like that straw or hay I was talking about that you put on top of a hard soil, and it will change the physical condition. That's what we're meaning here. Organic matter can improve physical condition, increase water infiltration, improve the tilth of the soil, decreases erosion losses, and supply plant nutrients. We can get all that from organic matter. It's a good thing to have, and it's a good thing to have as a continuous supply. Green manure crops work as excellent starter fertilizers. When you start looking at what's in a green manure crop and talk to a plant pathologist, they'll tell you, look, whatever is in that plant, the residue that you don't harvest and take away, when that decomposes in the soil, that's the most easily accessible nutrient for the next plant to take up and use. What's already been through a plant is easiest for the plant to take up and use, and they'll get that first as a source. So you take these green manure crops that are nice tender plants or whatever, and all of a sudden you put those in and they break down quickly, the plants will pick it up and use that, and it's a fast source of nutrition. It's like a starter fertilizer. We talk about organic matter and humus. Well, supplying organic matter helps feed that average size cow or those 4 average size cows in terms of an acre of soil organisms. But nutrients from minerals and humus also have to be there to feed the crops. We need enough for both. When you start looking at where do we need those nutrients, we need them in the aerobic zone. From grass to trees, everything from a grass plant to a hard woody tree. Roots feed by choice from the aerobic zone as deep as a fence post rods. Now you'll have other roots that go on down deeper, but they're more for the purpose of pulling in the water. And as they pull in the water, they'll also pull in water-soluble nutrients. But those roots up in the aerobic zone, because of the digesting that the microbes do and so forth, that's where the plant can most easily obtain the nutrients it needs. And we work with thousands and thousands of acres of tree crops. And one after the other, once we have those growers start to fertilize, not just under the trees, but in the middles out between, you'll see the roots from one row of trees crisscross from one row to the other. The roots will crisscross right underneath the soil. As little as a quarter of an inch, you dig out and you got white roots there moving between rows, because they're going to send those roots out to pick up those nutrients. The trees or any other crop that has a large root system can send those roots to where the nutrients are that they need. Now, when we say feed the aerobic zone, check the aerobic zone as deep as the fence post rights and try to get the nutrients corrected in there. This client grew fresh market herbs, and this is a 2.5 acre greenhouse of sweet basil. It was certified organic. It was 100%, they used 100% organic materials and so forth, just as a point that they were certified organic. But they balanced out their soils, and they grew a lot of other crops beside this, had greenhouses and truck crops, and they made their own potting soils. Well, they had the first time they contacted me, the manager said, we got some truck gardens that just won't grow anything. We get corn to grow, but it's like nubbins and they're so bitter you can't eat them. And he said, we've got another one. We planted in squash and it came up and got about, just a matter of starting to run, and they all died. So he said, another client that we had out there told him we ought to send some samples, and they did. And when he was sending the sample to the problem, I said, well, do you have a place you think is your best soil you've got? Oh, yeah, he said. Well, send a sample of that soil so you've got something to compare yourself. You know where the soil came from, but don't tell us which one's the good one. Send it from wherever it grows the best, and then send the problem so you'll know what's the difference in terms of the soil tests we're using. Well, he did that, and it was easy to pick out because that soil in that greenhouse had exactly the kind of nutrients. There are certain parameters. You don't have exact, but let's say we say between 10 and 12% magnesium, and that soil had it. We say between 68 and 70% calcium, that soil had it. And all the other things that we'd say, well, this is an ideal soil, that was an ideal soil. But I also asked them to send what they'd put on it so we could evaluate what more needed to be put on, not just on the problem soil, but they also sent it on that excellent soil. And when I saw all the stuff they put on that excellent soil, I said, this is your excellent soil, but in 3 years, you won't be able to grow anything in that greenhouse. And it was a loud laugh. They said, this is the best soil you'll ever find. And I said, it is now, but with all the stuff you just put on it, you're going to mess it up, and it's going to take about 3 years. Well, it was in sweet basil. And 3 years later, he called and said, Neil, where can we get some new soil? He said, all that sweet basil died. And he said, I forgot what you said. We planted in sweet basil again, and it all died. And he said, then I remembered. So he said, now we need to get new soil to put in there. And I said, well, you're building your own potting soils, and those potting soils are excellent in terms of the nutrient levels you have. Rather than taking out all that old soil, why don't you just take the potting soil and put down 6 to 8 inches of potting soil in black plastic, just cut off the black plastic 6 or 8 inches tall, put your sweet basil in there, and then those sweet basil plants will grow down and go right in, put their roots right into that so-called toxic soil, and they'll thrive and do well. The aerobic zone is what makes the big difference. If you can get them to feed there, well, this is a picture of the replant. They replanted it in sections, and this is a picture of the replant. When they did that, they didn't die. As a matter of fact, the farm manager said, it's the biggest sweet basil we've ever grown. It's the largest leaves, and it's the sweetest taste we've ever had. They put it, you can see those plastic, if you look there on that row, you can see those black plastic liners, and all that is just an open top and an open bottom. They put the plants in, and those roots went right down into that so-called toxic soil where nothing would grow in order to pull the moisture and stuff up. Aerobic zone and balanced nutrients, balance out your aerobic zone to get the best response. This increases soil fertility, improves yield, but how does it do it? Because in the aerobic zone is where we get the true soil health, what's most necessary. I'm not saying you can't kill something out, but if it's extremely bad down underneath, but those soils were not so bad that once you corrected the aerobic zone, the plants could actually harvest from where they couldn't survive before. When you use compost, that was one of the things that happened that I told them to be so bad, because they put about 50 tons of, equivalent about 50 tons per acre of compost in that place, and about 10 tons of gypsum equivalent, because they just measured out in buckets and put it in. Well, if you're going to use compost, first of all, see what your soil can stand and see what the compost has in it. Always get that compost and analyzed, and then look at, from what's in that compost, what's that going to do to the same nutrients in your soil? Is it going to build them up? Is it going to, many times we find if people make their own compost from their own stuff, what the soil's low in is what the compost is low in. And you can't correct that. You can't correct. If your soil's low in calcium and your compost is low in calcium, it's not going to correct your calcium that way. You got to get extra in there. So always get a nutrient analysis, and I don't mean just NPK. If you're going to analyze a compost, it's good to look at the calcium, magnesium, and sulfur. And if there's any chance sodium would be a problem, also the sodium, in addition to the nitrogen, phosphorus, and potassium. But I said all this, and now I want to say providing organic matter for building and maintaining humus is always a worthy goal. And if your soil can stand it, that works great. It's a key to better soil biology and to better crops. But the use of crop residues, manures, and compost is not the greatest key to increasing life in the soil. All these may be helpful or can be helpful practices. They're all useful tools for soil improvement, but never confuse the use of soil improvement methods as being the best answers to good soil health. Tim Reinbott is Assistant Director of Moses at University of Missouri. He's also Director of Field Operations for at that time when he started, it was over South Farm Research Center. Now he's over all the research stations in the state of Missouri. But Tim Reinbott actually came to me and said, Neil, we'd like to do randomized replicated experiments on the Bradford Research Farm at University of Missouri to check and see. He said, I've seen some places and people that are using the Albrecht system. And he said, I think it's time we took another look at it just to see how does it compare with what farmers are already being told what to do. He called it the Albrecht-Kinsey treatments because he said, I'm not sure we have any agronomists who understand what Dr. Albrecht would say needs to be done. So we'll get the agronomists to make the recommendations for the university. But he said, I'd like to hire you to make the recommendations for the Albrecht portion. So that's why they call it the Albrecht-Kinsey treatments. Dr. Albrecht probably wouldn't say exactly what I do because he knew a lot more, but he's not here to ask. But the original soil test on corn, the calcium was 70%, the magnesium was 13%. We like it to be 10 to 12, but that's a whole lot closer than most soils in the state of Missouri. 70% calcium, 13% magnesium. Now this is an average of all the plots on the test. Potassium was just above 2%. Phosphorus was minus 113 pounds. Calcium had 143 pounds more than what we'd say was 68% ideal. That's just a figure to shoot for. 70% is great. Magnesium was an extra 60 pounds over what we'd say. And that you can take that out in 2 years just by growing a crop. Potassium was minus 429 pounds to get to what would be considered as excellent. And there was a need for sulfur, boron, copper, and zinc. Now, there are people who say, well, you know, the soil is alive and it's the plant's stomach. So how do we utilize what we need in terms of promoting this to the greatest advantage? There are those, the reason I say there are those who study microbiology, and they say they maintain that farming and building soil biology are at odds with each other and therefore have no beneficial connection. In other words, they say, well, when you put on what the soil needs, that's too hard on the microbiology. Well, in this case, the Tim Reinbach decided to look at quite a number of things. And so he says, after 5 years of this, now it's up to 7 years, but after the first 5 years, then he gave the report showing where they had cover crops and where they didn't have cover crops, where they used the control, which was what would normally be said the farmer should use to grow corn, where they had the Albrecht recommendations, and then where they had Albrecht recommendations plus magnesium. Look at the fungi where they had the control, 2957 without cover crop, 3813 with cover crop. With the Albrecht recommendations, the fungi was 4,225, about 400 more in terms of measurement. And that was with cover crop. Without was 3388. Again, almost 400 pounds different. When you get down to the Albrecht recommendations with extra magnesium, and they were doing experiments to see, well, does extra magnesium help or hurt or not make any difference? Well, when they put that extra magnesium on, it was worse than the control where they used just a normal fertility program. So putting that extra magnesium had an adverse effect on fungi after 5 years of this program. The arbomuscular fungi. As you look across to the various ones, what you see is that where the Albrecht program was used, basically the microbes were better. Now on the one fungi there in the middle, the recommendation, the fungi was reduced. The control actually had better fungi in that one area of measurement than anywhere else. And Tim said, well, we're going to have to check further on this over the years. This was just one-time check after 5 years. But he said, I think it has to do with the effects of what the fertilizer materials, how the fertilizer materials stimulate organisms in the soil, and we're going to see that bounce back. I don't know yet because I haven't seen anything more. But if you look at this chart from what their experiments were after 5 years, everything else, where he says where you follow through on the recommendations as shown to be needed on the Albrecht test, the life in the soil is actually the best. So does putting on what's required, does that get hard on the microbes? Because we needed sulfur and we needed copper, and we needed boron, which are things a lot of microbiologists will say, well, those are too hard on organism. Well, they were applied, but over that period of 5 years, didn't make that much different. It didn't make that much negative problem. So the foundational key is not cover crops, adding compost and manures, or even building carbon levels in your soil. These practices help the living organisms in our soil, but they are not the true foundation on which to build soil health. There's something else that's more important for achieving true soil health. Growing good crops is the important and immediate short-term goal on each farm. Farmers have to consider this first to keep things going, to stay in business. In doing that, we always emphasize to a farmer, if you want to emphasize your crop, be sure you take care of nitrogen, phosphorus, potassium, and sulfur deficiencies first. Once you do that, then sufficient calcium or magnesium from the proper materials would be the second thing to look at. Generally, they would take second place to NPK and S if those are missing and you're trying to grow a crop. Then look at what liming materials you need. Then look at what difference micronutrients will make. All of them make a difference. But if you're starting to look at what's needed to grow the crop this year, primary elements first, secondary next, micronutrients generally would be last unless it's a severe deficiency. But soil health is a long-term project. It requires considerably more than just what we need for the current crop. The greatest question to ask here regarding soil health is, what are the requirements for life itself? Basic needs for life: shelter, food, water, air. And when you consider all those, even for us or for a plant, Which one is likely to make the least difference? The one at the top, shelter. A lot of times you can survive without shelter, a lot longer than you can without food. Most of the time, if you're not in a real adverse environment. Shelter in under normal conditions would be the least worry. Food would be next, water would be next, but what is the most restrictive? Air. And when we really get down to it, air and water on soils turn out to be the two that are most restrictive. Which of these take precedence in terms of immediate survival? Air first, but then if you have enough air, then water. The basic requirements for correcting each different soil in order to achieve excellent soil fertility provides the foundational keys for real soil health. Why is that? First of all, consider the best possible yields and quality can only be achieved on soils with the proper structure already in place. What's the proper structure? 45% to 45 to 47% minerals, 3 to 5% humus, and on the other side of the chart, 25% air, 25% water. That air and water is critical. How do you make sure you have the right amount of air and water in a soil? If you take a soil like this is a soil from Torrington, Wyoming. This soil has an excellent Albrecht balance, and it's not because we were working with it. It had it when we got there. But you know what? Farmers can pick out those soils because those soils always have great structure. They're easy to work. They're hard to compact. If you don't just abuse them, they're going to work real well. Why is that? If you take that soil and analyze it, if you have a soil physicist analyze it, he'll tell you, well, these soils have the right amount of air and water. If you had Dr. Albrecht analyze that soil for nutrient value, he'd say, well, these soils have the proper chemistry as well. You have to have the proper chemistry in a soil, or you will not have the proper structure in a soil. Chemistry is the key to building soil structure. Once you get the chemistry right, the soil structure will be right. Once you get the soil structure right, you've built the environment, the best environment for the living organisms in the soil, from the plant root to everything that supports it. To me, that's true soil health. When you start looking at textbooks, they tell you the ideal soil is 50% solid and 50% pore space. The solids part is comprised of minerals and organic matter. The portion, the pore space is air and water. Now, when we start talking about that, the air and water, how do you determine if that's going to be there? I don't know any other way, not by looking at pounds per acre. We have to measure what the amount of negative charge is in that soil, which we call the exchange capacity. And we have to measure the percentage of each one of the cations, calcium, magnesium, potassium, and sodium in particular, and then combine that with pH to tell whether we have the correct amount of all those nutrients. Now, right down at the bottom of the paragraph there, we see a soil that has a TEC, or an electrical charge, of 20 to 25. Some people say CEC, cation exchange capacity, but that can only reflect, sometimes CEC can be just calcium, magnesium, potassium reflected in that. The numbers will be completely different if that's the case. Dr. Albrecht always said we need to include sodium and other bases as well, and that is what he called the total exchange capacity, or TEC. So if we've got 20, if you've got an exchange capacity of 20 or 25, the base saturation should be 68%. Ideal base saturation is 68% calcium, 12% magnesium. If you've got 65 to 70% calcium and 10 to 12% magnesium, if you could get any variation in there, most farmers would say, I can't tell the difference. I'd say, I can't tell the difference. All of those are going to be good soils, but that 68-12 is more or less a bullseye target to shoot for. If you're not right on it, it doesn't mean you're going to have a bad crop. It just means that we got to get close to that area. So in a heavy soil, 68% calcium and 12% magnesium is needed in order to have the correct pore space, the right amount of air and water. And what's the problem with a clay soil? Too much water, not enough air. As a general rule, if you've got a problem with a clay soil, with the structure of that soil, it's going to be more water, less air. We need to increase the airspace, or we need to increase the aeration of that soil. On the other hand, a soil that has a TEC of 5 would be classified as a very sandy soil. And that soil should have a base saturation of 60% calcium and 20% magnesium, less calcium and more magnesium. Why is that? Because calcium increases soil porosity, magnesium reduces soil porosity. They both have opposite jobs. Calcium actually pulls the clay particles together, causes them to clump up, and it actually increases more porosity, more pore space in the soil. Magnesium causes those clay particles to spread out, and it reduces the porosity of the soil. What do we need in sand? In sand, we have too much air, not enough water. So there, we de-emphasize as much as possible the calcium and emphasize as much as possible the magnesium, as long as we can do that and still provide the right nutrients for the crop. Okay, I'm supposed to go for an hour on this, and I pared this down from 90 minutes, from 90 frames to 75, and I knew I might not get through it, but I think I've given you here, it's been about an hour, and I've given you the basics in terms of what needs to be done. There are a few more soils here, but it might take another 15 minutes, and I don't want to encroach upon anybody's time. So I'm going to yield to Van here in terms of, I think people may have questions or whatever. Van, if you're there and hear me, can we go from here to there?
Actually, Van, this is Melissa. I'm Van's coworker. He's having some technical difficulties at the fairgrounds, so their internet has gone out. So I don't know if anybody has any questions out there. If you want to ask or put in the chat or something, but right now there are no questions.
I got a question about Daken radishes. I heard you speak on them one time.
About what now, Carlos?
I heard you talk, or maybe in an article in Acres USA, you talked about Daken radishes.
He's talking about daikon.
The daikon radish. Yeah, the German.
Okay, yeah,
the Japanese radish. What's your question about it?
I think I heard you say like one time it was good, like for the soil to loosen it up or something like that, maybe.
There are a number of people that plant daikon radish in order to use that to the roots from the radishes to help in terms of loosening a soil. That's right.
Okay.
It's a part of a lot of people's cover crops even.
Oh.
Neil, the way I look at that is a good cover crop of rye in the winter with maybe some legume mixed in will do a better job of opening the soil than the daikon.
I would say that rye is a great cover crop as long as you don't let it get out of hand and know how to control it.
Right. I tell them, don't put it on your whole area, because if you want something early in the spring, you're not going to do it with rye.
Well, yeah, but we have a lot of people that do use rye as a part of the cover crops, and I would say I'm not the biggest expert on what's the best in all cases, but I'd say you experiment around a little bit there. But rye works great, but a good mix of things can add to well, depending on what you're trying to accomplish. A good mix of various things in a cover crop can give you a little bit more, what should I say, flexibility. There was a question that came on just for a moment, and I didn't get. It was about copper and sulfur, I think.
Yeah, it says in relation to soil health, what can be done to improve the levels of copper and sulfur in soils when producing vegetable crops?
Well, there's considerable amount of disagreement depending on who you're talking to. And I will say that I didn't say this in the beginning, but we work with conventional growers. We work with certified organic growers. We don't try to tell the farmer, this is what you need to do. We ask the farmer, well, what are you doing and how can we try to help you in terms of fertility? And many organic certifiers object to the use of the only source of material that I know that will build copper in the soil, and that is copper sulfate. But don't just go out there and put it on indiscriminately. Copper sulfate can be toxic to organisms, but principally, here's the thing to consider when we say that, and that is, if you take dry copper sulfate and broadcast it, and you put on 5 pounds of 26% copper sulfate per acre, that 5 pounds of 23%, actually 23% copper sulfate, but whether it's 23 or varies from that, the standard we try to use is 23%. But when you put that on, if you put it on at the rate of 5 pounds per acre, it takes about 12 months before it will show up on the soil test, but it'll raise that soil test by 0.3 parts per million. You only get about 25% effectiveness out of copper sulfate. Even though everybody says it's real soluble, it's still, copper is a very strong metal to stay in the soil. When you put that on and you go out there and look at 5 pounds per acre, there's a little blue-green dot here and a little blue-green dot here. If you mix it into the fertilizer and spread it, it looks like there's not enough to do anything. What I'm saying there, when you spread it dry, you don't cover the whole soil. And where you get some moisture and that copper breaks down, it is going to be somewhat hard on some organism there for just in the very beginning. But when copper is spread on the soil, it very quickly converts to a form that's not harmful to the microbes at all. The place where we get in trouble using copper sulfate is using it as a liquid. When you put it on as a liquid, now you cover the whole soil with it, and it's going to be a whole lot harder on the microbes. Even using copper sulfate as a foliar spray is going to be harder on the microbe. Not saying they won't come back, because eventually they will, but in terms of foliar copper, if you're feeding the plant, use a soil test to feed the soil, use a plant test to feed the plant. If you're feeding the plant, then use copper chelate or some other form of copper, because copper sulfate can be harmful to the organism that's on the plant that you're spraying, not just detrimental, but also beneficial organisms. So building copper, if you mix the copper sulfate in with dry material, 5 pounds of 23% copper sulfate will build your copper levels by 0.3 of a part per million. That's on the test that we use. That's about 25%. In other words, for every pound of copper you put on, you get about 1/4 of a pound of effective copper built up in that soil. But the other side of that is, once we ever get that copper to the place where we need it, or where the farmer or the grower says, well, this is where I want to be, then we've got people that put copper on in the 1970s that have never had to do it again. The soil is still testing that they have adequate copper. And I think it's because 75% of it that we put on then was still in that soil, and we're still seeing the benefit from that. We'll eventually get to the place where somebody will have to put on some copper. But the people that build their copper levels up to good levels, it takes years and years and years. I mean, some of those guys, look, 1978 was when we first started using copper sulfate. We've got people that haven't had to put it on again since. As far as sulfur, if you're growing grass crops, or if you're growing legumes, if you're growing grass crops especially, but a lot of people say, well, you can't put elemental sulfur on legumes and get the sulfur into the plant. If you use rock sulfur, that's true. If you use popcorn sulfur, that's true. But if you use water soluble elemental sulfur, a sulfur that will dissolve, if you put it out on the soil, you might see it after a rain or two, but within a matter of weeks, that sulfur is dissolved and gone. That sulfur will get into crops within a matter of 7 days. So you can use elemental sulfur and spread that on a soil, and especially if we're coming into the autumn like now, elemental sulfur, if you put it on, it will tend to last for about 12 months and then it'll be gone again. In other words, we can't keep even elemental sulfur in a soil that's really biologically active. It's hard to keep that sulfur in the soil. So what we tell clients is put your sulfur on. If you need materials like copper sulfate or other, that sulfate's going to supply some sulfur. But we always want to see a minimum of 20 parts per million elemental sulfur in an available form in a soil at all times. If you don't have that, then the microbes are suffering, the plants are suffering, the soil is suffering. So we always encourage our clients to measure how much sulfur they already have in the soil. Whatever they're lacking to get to 20 parts per million, put that on as elemental sulfur. And then if you're using sulfates like potassium sulfate, even certified organic growers can use potassium sulfate. Any other form of sulfate, count that as incidental. Use the elemental sulfur to build up the level. That's a short answer. There's probably a lot more that could be said on either one of those.
Okay, Carlos, did you have a question?
Yeah, I wanted to ask Neil, it seems like on our soil, we've applied magnesium 3 times and it doesn't seem to hold or not showing up on the test. It's kind of weird. And we have kind of a sandy soil.
All right. You've applied magnesium 3 times. Have you looked, before you tell me how much you're putting on, have you looked to see how much magnesium that crop will take out every year? And how does that match up with what you're looking at? For example, if we're looking at tree crops, generally we expect it's going to take 30 to 50 pounds of magnesium per year minimum just to feed what the tree needs. And if you're putting on that much or less, it's not, you got to put on more than that. You got to put on more than what the crop required and what the biology of the soil required in order to get that level to build up. So are we recommending magnesium to you because your soil is extremely deficient? And if so, are we giving you a recommended amount and then a minimum amount? Because most people say, well, you know, if I spend what it takes to build all that magnesium up, it ruins my fertilizer budget. So maybe you, with that said, maybe you can give me a little bit more information.
Yeah, I think we were trying to get it to the, I guess, to the minimum 10%, 12%.
Yep.
Or on the Albrecht model.
And getting it to that 10%, did we make 2 recommendations? One that's a bigger recommendation, one that's a smaller one?
No, I do the excellent. So the first time around we put like close to 1,000 pounds of K-Mag.
Okay, how long ago was that?
Oh, that's probably been about 4 years ago.
Okay, 1,000 pounds of K-Mag. Yeah, that. Did you also put on any calcium?
No, our grounds was running high in calcium, like 80%.
Okay, all right, that's the other side of it. Carlos, I have to look at soil tests. I see so many. I didn't remember that your soil was high in calcium, but when you have a high calcium level as in the soil, if you come in and work that soil and increase the percentage of calcium, it will decrease the percentage of magnesium. Any chance that your calcium has gotten higher, or is it just holding where it's always been?
Yeah, I think it may be in the water because it seems like it increases.
There you go. Yep. Yeah, Bill Brush is going to put on a presentation on water just after the tree course we're having in California in December. And that's what he says. If you got the calcium in the water, it will actually cancel out so much of the effects of the it will cancel out so much of the effects of the magnesium we're adding. We have to calculate that in and add that much more. So until you consider that water, I suspect that's what's happening.
Okay, thank you.
Neil, I have a neighbor that has very, very high calcium and very low magnesium and very low potassium. I'm assuming that maybe Sulfomag might work in that situation.
Well, yes, Sulfomag might work in that situation, but if you say very high calcium, if the calcium is above 84%, then that calcium is there. There's not room enough to have more than 84% calcium on a attached to clay particles in a soil if all the other nutrients are there as well. So what I'm saying there is anytime the calcium on the test that we're using shows above 84%, it's overexpressing the exchange capacity on that soil. And there's another test that should be done if this is a small garden, it may be a matter of just saying yes because the guy may not want to spend the money. But there's another test that we recommend called the cation displacement test. And that test is used to determine the true exchange of a soil. The true exchange capacity is not determined by the Albrecht test because he uses the sum of the cations. Well, that just adds up all the cations, whether they're attached to a clay particle or not, it assumes they are. What we need to know is how many clay particles are there to attach to, and that adds about 50% to the cost of the test. So people that have small needs don't necessarily want to run that, but we have a tremendous amount of clients that run hundreds of those because otherwise that 84% or higher calcium can make it look like you have a magnesium deficiency because the exchange capacity is being expressed as too high. As soon as you determine the true exchange capacity, all of a sudden, sometimes one or the other, it's only one or the other of those two that's missing, and that's why your garden is not doing well. If they got a garden with above 84% calcium and they're raising a good garden, and there are soils that are like that, then I would say you need to be real careful about putting very much K-Mag or Sulfomag there.
Okay. I'm not sure what her percentage of calcium is, but her pH was like 7.3 or 4. And apparently the extension agent said any soils down in that area are very high in pH. He didn't say high in calcium, just high in pH.
And they will be.
Yeah.
Yes, we see many of those soils, and those soils come from all over the world. The ones some that stand out particularly for me is the White Cliffs of Dover in England. It's not unusual for some of those soils to come back at 94% calcium. But all we have to do then is find out, do we have enough saturation of potassium and magnesium to grow the crop? And if we don't, put that much on and no more, and all of a sudden you can get those soils to grow.
And would ammonium sulfate help in a situation like that where you have will the sulfur and the ammonium sulfate take out some of that calcium?
Well, it will take out some calcium, all right. But in general, if you have a medium to heavy soil, it'll take out so little. It's what we tell our clients. If you add the calcium, magnesium, and potassium together, and that totals 93% or higher, and you're willing to spend enough money to keep your potassium level up and to make sure you have plenty of trace elements, it's better not to try to get that calcium out. It's better to supply the things the calcium is tying up.
Okay. Well, it's not a heavy soil. It's like I think it's around 7 CEC.
Okay. In that kind of a case, it might be worthwhile, but just what you have to do is sit down, determine the amount of the true exchange capacity, and then calculate how much excess the calcium is there. And for every pound of excessive calcium you have, it's going to take 2 pounds of sulfur over and above what the crop and all the biology takes to take that extra calcium out. Most of the time that turns out to be so costly, people will decide they don't want to do it.
Okay.
Hey, Neil, it's Paul.
Yes, Paul.
The gentleman who talked about putting 1,000 pounds of K-Mag, with our experience over here in California, is breaking up that shot maybe 3 times. a little over 300 pounds at a time versus one big slug, you probably could have got a better reaction in the soil.
Okay. All right. You hear that, Carlos?
Yeah, actually, I think I spoke to you about 2 years ago, and they miscalibrated the spreader, and we
Yeah.
got like a double spread on part of the field, and the magnesium and the potassium are holding really well there. We thought we were going to kill the trees. They're the ones doing the best.
Well, I guess it just proves you need more. You need more of it.
I think it probably pushed that sodium out of the way.
Don't just arbitrarily do that. Go ahead and measure and make sure, because sometimes those numbers can change a little bit more over a year or two. So
Yeah.
Yes, they can.
All right. There's another question in a couple more, but one is considering no-till systems versus various tillage programs, which tillage no-till system do you see as being the most beneficial in terms of soil health?
in terms of, depending on whether what all is included in there, to me, and please, I'm no expert in all the different systems and so forth, but to me, in terms of trying to feed the soil and let the soil feed the plant, strip till seems to be a much safer system, using strip till and broadcasting the materials that'll make the most difference, putting a little bit extra down in terms of strip till.
Okay. And then there was one other question. Can you suggest a test service? Is that what you do, and what is the cost?
A
I'm not
test
sure
for,
exactly. Yeah.
could we suggest a test for which form of no-till is best or something else?
No, something else. I'm not sure what exactly she was asking.
If it's talking about the cation displacement, yes, we do tests for that. And basically, if it's talking about the copper or the sulfur, yes, we do tests for that. The copper and the sulfur is a part of our standard analysis. Our standard analysis includes the phosphorus, sulfur, iron, manganese, copper, zinc, potassium, and sodium. In addition to the amount of negative charge, the exchange capacity of the soil, and the pH, and the colloidal humus.
And boron.
Thanks. And boron.
Okay, does anybody have any other questions?
Well, if not, I'd like to say thanks to everybody. Hope everybody has a good week.
Well, thank you, Neil, for the great presentation.